The kinetics of a chemical reaction is defined as the rate at which an amount of reactants is converted to products per unit time. So if we consider the rate of change of a reactant with respect to time, which is a change in concentration of the reactant on a change in time. Well, the rate of the reaction is equal to the rate at which the reactant is consumed on the stoichiometric coefficient. And a negative sign indicates that the reactant is being consumed. So the concentration of the reactant is dropping from the initial concentration. And similarly for reactant B, we have the rate of change of the concentration of reactant B with respect to time on the stoichiometric coefficient, and that's equal to the rate at which the product is formed on the stoichiometric coefficient. And a unit of the rate of the reaction is in molar per second, or moles per litre per second. Several factors can increase the rate of a reaction, and one of those is the concentration of a reactant. So for example, if the concentration of hydrochloric acid in this reaction increases in an aqueous solution, then more collisions between these hydronium ions are going to occur with the aluminium solid bar, which thereby increases the rate of the reaction. Now another factor is temperature. So an increase in temperature causes more collisions between the molecules and the aluminium solid, and thereby increases the rate of the reaction. And another factor is surface area. So if you break the aluminium bar into two, so you have more aluminium atoms on the different sides of these bars that can collide with the hydronium ions, and this thereby increases the rate of the reaction. And catalysts can also increase the rate of the reaction, which we'll look at in more detail. But basically, catalysts do not participate in a reaction. They just increase the rate of a reaction by decreasing the activation energy, which is the energy required to initiate the reaction. And other environmental factors such as pressure, phase changes, and so on, can influence the rate of the reaction. Ammonia decomposes at the following rate, and we're asked to find the rate of production of nitrogen and hydrogen gas. Well, first we need to make sure that this reaction is balanced, and then we can write the rate of the reaction using the stoichiometric coefficients. So we have the rate of decomposition of ammonia and the rate of production of the gas products. And now if you substitute for the given quantity of the rate of decomposition of ammonia and negative because the reactant's being consumed, then you can solve for the rates of production of both gases. Now if the initial concentration of ammonia is 0.024 molar, what is the concentration after 1.5 seconds? So we have the change in concentration of ammonia over time is equal to the concentration of ammonia at 1.5 seconds minus the initial concentration, which is given, and that's divided by the change in time. And we have the rate of decomposition given in the problem, so you can solve for the concentration of ammonia at 1.5 seconds.